November 1942. Guadalcanal. The night air hangs thick with heat and the smell of burning fuel. Marine riflemen crouch in foxholes along the perimeter of Henderson Field, listening to the jungle breathe around them. Above them, the tropical sky flickers with distant artillery fire. Just hours ago, this airstrip was little more than a dirt scar, hacked through the palms by Japanese engineers before the Americans arrived. Now, as dawn breaks over the Solomon Islands, something extraordinary is happening. Dozens of men in khaki work clothes and construction helmets are already moving across the runway with graders, rollers, and surveying equipment. They work with rifles stacked nearby, ready to drop their tools and fight if the Japanese counterattack. These are not soldiers in the traditional sense. They are the Seabees, the United States Navy's construction battalions, and they are about to accomplish something the enemy high command will refuse to believe is possible. Within 3 weeks, these men will transform this contested patch of coral and mud into a fully operational bomber base capable of handling the heaviest aircraft in the American arsenal. The Japanese, watching from their positions in the hills, will report back to their commanders with mounting alarm. American heavy bombers are landing. American fighters are operating in squadron strength. The airfield that should have taken months to complete is already functional. In Tokyo, intelligence officers will study these reports with skepticism bordering on disbelief. Their own construction timelines, their logistical models, their entire understanding of military engineering tells them this should not be possible. But across the Pacific, on island after island, the Seabees will repeat this performance. Guadalcanal, Espiritu Santo, Ifate, Tarawa, Saipan, Tinian. Each time they will build bomber-ready runways in 20 days or less, and each time they will move American air power hundreds of miles closer to the Japanese homeland. This is the story of how a group of civilian construction workers in military uniform became one of the most devastating strategic weapons of World War II. This is the story of the men who built victory, one airstrip at a time. To understand the shock that rippled through Japanese military headquarters when the Seabees went to work, you must first understand the state of military construction in 1941. When the United States entered World War II, the Navy had no dedicated construction force. Military engineers existed, of course, but they were designed for European-style warfare, building fortifications, bridges, and supply depots in relatively civilized terrain, with months of planning and logistics support. The Navy had the Civil Engineer Corps, a small group of commissioned officers who supervised shore facility construction during peacetime, but these officers had no enlisted men under their command, no heavy equipment, and no combat training. When war broke out in the Pacific, this system collapsed almost immediately. The problem was the nature of the Pacific theater itself. This was not France or North Africa. The Pacific War would be fought across thousands of miles of open ocean, on hundreds of islands that appeared on maps as mere dots. Most of these islands were undeveloped. No roads, no ports, no infrastructure of any kind. They were covered in jungle, surrounded by coral reefs, and utterly hostile to modern military operations. Yet American strategy demanded that these islands be seized and transformed into forward operating bases at breathtaking speed. Every island captured was a stepping stone toward Japan. Every airfield built extended the range of American bombers. But building those airfields required something the U.S. military simply did not have: a large, mobile, combat-ready construction force that could operate under fire in the world's most challenging environments. The solution came from an unlikely source. In late 1941, Rear Admiral Ben Moriel, chief of the Navy's Bureau of Yards and Docks, proposed a radical idea. He wanted to create construction battalions composed entirely of civilian construction workers, carpenters, electricians, heavy equipment operators, engineers, and foremen, who would be recruited directly from the private sector, given military training, and deployed to combat zones as naval personnel. The concept was revolutionary. Traditionally, civilians in war zones operated under contract and had no military status. They could not carry weapons, could not be ordered into danger, and could not be subjected to military discipline. But Moriel understood that the Pacific War would require construction workers to operate on the front lines, often under enemy fire. They needed to be able to defend themselves and their work sites. They needed to be part of the military chain of command. In December 1941, just weeks after Pearl Harbor, the Navy authorized the formation of the first construction battalions. The name was quickly abbreviated to CBS, which became Seabees, a name that would become legendary. Admiral Moriel was not simply a bureaucrat pushing paper in Washington. He was a visionary who understood that modern warfare had fundamentally changed. The age of static fortifications and predictable battle lines was over. The Pacific would demand mobility, flexibility, and above all, speed. Moriel had spent years in the Civil Engineer Corps and had witnessed firsthand the inadequacies of the traditional system. He had seen civilian contractors refuse to work in dangerous conditions. He had seen projects delayed for months because the right equipment or expertise was not available. He had seen the military's inability to adapt civilian construction practices to combat requirements. His solution was elegant in its simplicity. Militarize the construction workers themselves. Give them ranks, uniforms, and military authority. Train them to fight as well as build. Make them an integral part of the naval force structure. The Navy brass initially resisted. Admirals were accustomed to commanding ships and sailors, not construction crews, but Moriel was persistent, and the desperate situation in the Pacific made his case for him. The Navy needed a solution, and the Seabees were it. The recruitment drive that followed was unlike anything in American military history. The Navy went looking for men with very specific skills. They wanted bulldozer operators who could clear jungle and move earth. They wanted carpenters who could frame buildings in their sleep. They wanted electricians, plumbers, welders, mechanics, and surveyors. They wanted men who had built roads, bridges, dams, and skyscrapers. They wanted, in short, the workforce that had built modern America. And they wanted them immediately. The call went out to construction sites, steel mills, shipyards, and engineering firms across the country. The age limit was raised to 50, far older than standard military recruitment, because the Navy needed experience, not youth. Men who had been building America's highways and skyscrapers suddenly found themselves trading their civilian hard hats for Navy helmets. They brought with them not just skills, but an entire culture of American construction work, the can-do attitude, the competitive pride, the rough camaraderie of men who measured their worth in what they could build. The men who answered the call came from every corner of America. There were loggers from the Pacific Northwest who knew how to fell trees and clear land. There were oil field workers from Texas and Oklahoma who understood heavy machinery and drilling operations. There were iron workers from the steel towns of Pennsylvania who could weld and fabricate under any conditions. There were highway construction crews from California who had built roads through mountains and deserts. There were carpenters from the Midwest who had framed thousands of houses. There were electricians from the cities who could wire anything from a skyscraper to a power plant. These men ranged in age from 18 to 50. Many were in their 30s and 40s, too old for standard military service, but perfect for the Seabees. They had families, mortgages, established careers. They left all of it behind to join a military unit that did not yet fully exist, to learn jobs they had never trained for, to fight a war in places they had never heard of. Their motivation was partly patriotic duty, partly the good pay the Navy offered, and partly the simple fact that they were builders who wanted to contribute to the war effort in the way they knew best. The first Seabee battalions were organized in early 1942. Each battalion consisted of roughly 1,000 men divided into companies of 200. Unlike traditional military units, Seabee battalions were designed to be completely self-sufficient. Each battalion had its own carpenters, electricians, heavy equipment operators, mechanics, surveyors, and engineers. Each battalion carried its own equipment: bulldozers, graders, rollers, pile drivers, concrete mixers, generators, and thousands of tons of supplies. Each battalion was trained not just in construction, but in combat. The Seabees learned to shoot, learned small unit tactics, learned how to defend their work sites. Their motto became, "We build, we fight." And unlike most military mottos, this one was literal. The Seabees would spend their days building airstrips and their nights defending them. They would operate bulldozers under sniper fire. They would pour concrete while artillery shells burst overhead. They would become, in the words of one Marine general, the toughest damn construction workers who ever lived. The training regime for the Seabees was intense and unusual. At facilities like Camp Peary in Virginia and Camp Endicott in Rhode Island, recruits underwent abbreviated but comprehensive military training. They learned to march, salute, and follow orders. They learned military discipline and chain of command. They were taught weapons handling, small unit tactics, and basic combat skills. But unlike regular boot camp, the emphasis was always on practical application. The Seabees trained with the understanding that they would be working, not fighting, most of the time, but they needed to be ready to fight at a moment's notice. They practiced setting up defensive perimeters around construction sites. They learned to work while wearing helmets and keeping weapons close at hand. They drilled on how to respond to air raids, artillery attacks, and ground assaults, while minimizing disruption to construction schedules. This dual nature, builders who could fight, fighters who could build, became the defining characteristic of Seabee training. Alongside the military instruction came advanced construction training. Even men with extensive civilian experience needed to learn military engineering standards and techniques. They studied military specifications for runways, roads, and facilities. They learned to work with military supply systems and requisition procedures. They practiced rapid construction methods designed for combat zones where time was always critical. They learned to improvise with whatever materials were available. A Seabee might need to build a bridge using salvaged steel from a wrecked ship, or construct a building using timbers cut from local jungle, or devise a water purification system from parts of damaged equipment. The training emphasized creativity and problem-solving as much as technical skill. The instructors were often veteran construction foremen and engineers who brought decades of real-world experience to the classroom. They taught the recruits not just how to build, but how to build under impossible conditions with inadequate resources and constant pressure. By mid-1942, the first Seabee battalions were deploying to the Pacific. Their timing could not have been more critical. The Japanese had spent the first 6 months of the war conquering a vast empire stretching from Burma to the Gilbert Islands. They had seized strategic bases, built fortifications, and established what they believed to be an impregnable defensive perimeter. But in August 1942, American Marines landed on Guadalcanal in the Solomon Islands, marking the first major Allied offensive in the Pacific. The objective was Henderson Field, a partially completed Japanese airstrip that would give the Americans a forward airbase within striking distance of Japanese supply lines. The Marines took the airfield in the initial assault, but taking it was only the beginning. The real question was whether the Americans could hold it and make it operational before the Japanese counterattacked. This was where the Seabees entered history. The 6th Naval Construction Battalion landed on Guadalcanal just days after the Marines secured the beach. What they found was barely recognizable as an airfield. The Japanese had cleared a runway through the jungle and laid down some gravel, but the surface was uneven, poorly drained, and far too soft to support heavy aircraft. Rain turned it into a swamp. The jungle pressed in on all sides. There were no taxiways, no revetments, no fuel storage facilities, no maintenance areas Japanese bombers attacked daily. Japanese warships shelled the field at night. Japanese artillery in the surrounding hills fired on the runway whenever aircraft tried to land. The Seabees looked at this primitive strip and understood they had to transform it into a fully operational bomber base while under constant threat of Japanese attack, and they had to do it fast. The Seabees went to work with an intensity that stunned even the Marines. They worked in 12-hour shifts, then 16-hour shifts, then around the clock without stopping. Bulldozers roared through the jungle, clearing trees and leveling ground. Graders scraped and smoothed the runway surface. Rollers compacted the coral base again and again until it could support the weight of a fully loaded bomber. They built drainage ditches to channel away the tropical rains. They constructed taxiways and parking aprons. They dug revetments, protective earthworks that would shield parked aircraft from shrapnel. They built fuel storage tanks and pumping stations. They erected maintenance hangars and operations buildings. They laid pierced steel planking over soft spots to reinforce the runway. And they did all of this while Japanese artillery bombarded the field from the hills and Japanese warships shelled it from the sea at night. Seabees learned to dive into foxholes when the shells came in, then climb back out and return to work once the barrage lifted. They learned to work by feel in total darkness because lights would draw enemy fire. They learned to ignore exhaustion and fear because the mission demanded it. The daily routine on Guadalcanal during those first weeks was a grinding test of endurance. The Seabees would wake before dawn, gulp down whatever breakfast was available, usually cold rations because hot food required fires that could draw enemy attention, and be at their workstations by first light. The construction site was organized with military precision. Survey teams would mark out the day's work areas. Equipment operators would fire up their machines. Work crews would organize their tools and materials. Then the work would begin. Bulldozers would push forward, clearing vegetation and moving earth. Behind them, graders would level and smooth. Behind the graders, crews would spread and compact coral. Other teams would work on drainage systems, digging ditches and laying culverts. Still others would construct revetments and parking areas. The work proceeded in coordinated phases, each team dependent on the work of the team before it. Supervisors moved constantly through the construction site, checking progress, solving problems, adjusting plans as conditions changed. The noise was constant. Engines roaring, equipment clanking, coral crushing, men shouting to be heard over the din. Then the Japanese would attack. Sometimes it was artillery fire from the hills, shells screaming in without warning and exploding across the runway. Sometimes it was air raids, Japanese bombers appearing overhead and dropping their loads while Seabees scattered for cover. Sometimes it was naval bombardment at night, Japanese destroyers moving close to shore and shelling the airfield with their deck guns. The Seabees learned to read the signs of incoming danger. They learned what an approaching aircraft sounded like. They learned to recognize the whistle of incoming artillery shells. They learned to tell the difference between friendly and enemy naval gunfire. And they learned to react instantly. When the warning came, they would abandon their equipment and sprint for the nearest foxhole or bomb shelter. They would hunker down while explosions tore through the construction site, throwing up geysers of coral and earth, shredding equipment, sometimes killing or wounding men. Then, when the attack ended, they would climb back out, assess the damage, and resume work. Destroyed equipment would be pushed aside or quickly repaired. Crater holes in the runway would be filled and compacted. Casualties would be evacuated to the field hospital, and the construction schedule would continue with barely a pause. The results were astonishing. Within 3 weeks of landing on Guadalcanal, the Seabees had transformed Henderson Field into an operational air base. American fighters began flying combat missions. Dive bombers began attacking Japanese shipping. Within a month, the field could handle heavy bombers. The Japanese, watching from their positions in the jungle, could not believe what they were seeing. Their intelligence reports described American aircraft operating in force from a base that should not yet exist. Japanese commanders had calculated that building an airfield on Guadalcanal would require at least 3 months, probably longer given the terrain and the combat conditions. Yet here were American planes, landing and taking off from a fully functional runway after less than 30 days. The Japanese High Command studied these reports with growing alarm. Either their intelligence was wrong, or the Americans had developed some new capability that Japanese planning had not accounted for. The truth was the latter. The Seabees represented a fundamental revolution in military engineering, a construction force that could operate at wartime speed in combat conditions. But Guadalcanal was only the beginning. As American forces pushed across the Pacific, the Seabees followed close behind. On Espiritu Santo, in the New Hebrides, they built a massive bomber complex that became one of the primary staging bases for operations in the South Pacific. The work on Espiritu Santo demonstrated the full range of Seabee capabilities. They built not just airfields, but an entire military infrastructure from nothing. They constructed port facilities to handle the massive amount of cargo flowing through the base. They built fuel storage farms with thousands of barrels of aviation gasoline. They erected warehouses, barracks, hospitals, and administrative buildings. They laid miles of roads connecting different parts of the base. They installed electrical systems, water systems, and communication networks. They built recreation facilities for the thousands of troops stationed there. Espiritu Santo became a small American city in the middle of the Pacific, and the Seabees built it in a matter of months. On Ifat, they constructed multiple airfields to support the Guadalcanal campaign. Each time, they worked with the same relentless speed. Each time, they delivered operational airfields in 3 weeks or less. The pattern became predictable. Marines or Army infantry would seize an island. Within hours, Seabee battalions would come ashore with their equipment. Within days, bulldozers would be clearing jungle. Within 2 weeks, the runway would be taking shape. Within 3 weeks, American aircraft would be operating from the base. The Japanese watched this happen again and again, and each time it defied their understanding of what was logistically possible. The secret to Seabee speed was not magic. It was a combination of factors that, when brought together, created an unprecedented construction capability. First, the Seabees had the right people. These were not conscripts learning construction from scratch. These were professional construction workers with decades of combined experience. When a Seabee battalion landed on an island, they had men who had built everything from highways to skyscrapers. They could look at terrain, understand its challenges, and immediately know what needed to be done. They did not need detailed instructions. They did not need constant supervision. They knew their jobs, and they executed them with professional competence. A Seabee bulldozer operator did not need to be told how to clear land efficiently. He had been doing it for 20 years. A Seabee carpenter did not need instruction on how to frame a building. He had framed hundreds of them. This level of expertise meant that Seabee units could hit the ground running and maintain maximum productivity from day one. Second, the Seabees had the right equipment. Each battalion deployed with an enormous amount of heavy machinery, dozens of bulldozers, graders, rollers, dump trucks, cranes, and specialized construction equipment. This machinery was not borrowed or requisitioned. It belonged to the battalion and traveled with them wherever they went. When the Seabees landed on a beach, their equipment landed with them. They could start work immediately without waiting for supplies or authorization. This self-sufficiency was crucial in the Pacific, where supply lines were long and unpredictable. The Seabees carried everything they needed to build an airfield from scratch. Their equipment was maintained by their own mechanics, fueled from their own supplies, and operated by men who knew every quirk and capability of the machines they ran. This integration of personnel and equipment created an efficiency that civilian construction companies would envy and that traditional military units could not match. The equipment itself was carefully selected for Pacific conditions. The bulldozers were usually Caterpillar D8s, massive machines weighing nearly 20 tons, with tracks that could grip on coral and mud, and blades that could push through jungle and move enormous amounts of earth. The graders were equally substantial, designed to scrape and level with precision even on rough terrain. The rollers were heavy compactors that could turn loose coral into a surface as hard as concrete. The Seabees also deployed specialized equipment that had been designed specifically for their mission. They had coral crushers that could process reef coral into usable construction material. They had earth augers for drilling holes for pilings. They had welding equipment, power generators, water pumps, and air compressors. They had machine shops mounted on trucks that could fabricate parts or repair damaged equipment in the field. This mobile industrial capability meant that a Seabee battalion could function almost independently of outside support for extended periods. Third, the Seabees had the right organization. Each battalion was structured to function as a complete construction company. They had engineers to survey and plan. They had operators to run the heavy equipment. They had carpenters to build structures. They had electricians to wire facilities. They had mechanics to keep equipment running. They had their own medical personnel, their own supply sections, their own administrative staff. A single Seabee battalion could accomplish what would normally require coordinating multiple military units and civilian contractors. This integration eliminated the delays and miscommunications that plagued traditional military construction. When the battalion commander gave an order, it was executed immediately by men who worked together as a team. There was no waiting for approvals from higher headquarters. There was no confusion about who was responsible for what task. The battalion commander could walk the construction site, identify a problem, and have it solved within hours because all the necessary expertise and equipment were already under his command. The internal organization of a Seabee battalion reflected this comprehensive capability. Each battalion was divided into 4 companies, each specializing in different aspects of construction, but cross-trained to support each other. One company might focus on earth-moving and heavy construction. Another might specialize in carpentry and structural work. A third might handle utilities, water, power, communications. The fourth might focus on roads and bridges. But all 4 companies could work on any task as needed. This flexibility was crucial in combat zones, where priorities could shift rapidly. If an air raid destroyed part of the runway, all 4 companies would immediately redirect their efforts to repairing the damage. If a new project suddenly became urgent, resources could be reallocated without bureaucratic delays. This organizational fluidity, combined with the professional competence of the men, created a construction force that could adapt to changing conditions faster than any civilian company. Fourth, the Seabees had the right materials. The Pacific Theater presented unique engineering challenges, and the Seabees developed innovative solutions. Traditional concrete runways required too much time and too many materials to build under combat conditions. Concrete had to be mixed, poured, cured, and finished, a process that took weeks and required enormous amounts of cement, aggregate, and water. Instead, the Seabees pioneered the use of coral as a runway base. Many Pacific islands had extensive coral reefs that could be crushed into a hard, compact surface. The process was ingenious in its simplicity. Seabees would use explosives to blast coral from the reefs. The coral chunks would be loaded onto trucks or barges and transported to a crushing plant. The crusher would reduce the coral to various sizes, from fine powder to coarse gravel. This crushed coral would then be spread across the runway in layers. Each layer would be wetted with seawater and compacted with heavy rollers. The calcium carbonate in the coral, when compressed and allowed to dry, would form a surface almost as hard as concrete. When properly prepared, coral runways could support even the heaviest bombers. They drained well, did not become muddy in rain, and could be repaired quickly if damaged. The technique required no imported materials and could be executed entirely with local resources. The Seabees also used pierced steel planking, interlocking metal plates that could be laid down quickly to create an instant runway surface. These plates, officially known as Marston Mat, after the town in North Carolina where they were developed, were engineering marvels. Each plate measured 10 feet long by 15 inches wide and weighed about 66 pounds. The plates had holes punched through them to reduce weight and allow water drainage, and they locked together with hooks along their edges. A crew of Seabees could lay hundreds of plates per hour, creating a runway surface that could handle fighter aircraft almost immediately. For longer runways or heavier aircraft, multiple layers of matting would be laid down. The pierced steel planking was particularly useful for emergency runways or for reinforcing soft spots in coral runways. It could be installed on almost any reasonably level surface, even if the ground was not fully prepared. This made it invaluable for creating operational airfields in record time. These innovations allowed the Seabees to build functional airfields without waiting for shiploads of concrete and asphalt. They could arrive on an island, assess the available materials, and construct a runway using primarily what they found on site. This local sourcing was not just a matter of convenience, it was a strategic necessity. Shipping space in the Pacific was at a premium. Every ton of construction material shipped from the United States was a ton that could not be used for food, ammunition, fuel, or other critical supplies. The Seabees' ability to build with local materials freed up shipping capacity for other needs and reduced their logistical footprint dramatically. A Seabee battalion could accomplish more with less support than any other construction organization in history. Fifth, and perhaps most importantly, the Seabees had the right attitude. These men brought the competitive, results-driven culture of American construction work to the battlefield. Seabee battalions competed with each other to see who could build faster. They took pride in finishing ahead of schedule. They thrived on challenges that seemed impossible. When told that a job would take 2 months, they finished it in 3 weeks. When told that conditions made construction impossible, they improvised solutions and did it anyway. This mindset, this refusal to accept limitations, became the defining characteristic of the Seabees. They did not make excuses. They delivered results. The culture was reinforced by the backgrounds of the men themselves. These were workers who had survived the Great Depression, who had learned to make do with whatever was available, who took pride in their skills and their productivity. They brought that Depression-era toughness and ingenuity to the Pacific, and it served them extraordinarily well. The competitive spirit among Seabee battalions became legendary. Units would race to see who could complete projects faster. Commanders would compare their construction records and boast about their battalion's achievements. This competition was encouraged by higher command because it drove performance to even higher levels. When one battalion completed a runway in 18 days, the next battalion would aim for 17. When word spread that a battalion had laid 1,000 yards of pierced steel planking in a single day, other battalions would try to beat that record. This friendly rivalry pushed the Seabees to constantly improve their methods and increase their efficiency. It also created a powerful sense of unit pride. Seabees identified intensely with their battalions. They wore their battalion numbers with pride. They told and retold stories of their battalion's achievements. This esprit de corps sustained morale even under the most difficult conditions. As the Pacific campaign intensified, so did the scope of Seabee operations. The island-hopping strategy developed by Admiral Nimitz required seizing and developing island bases in rapid succession, each one leapfrogging closer to Japan. Tarawa, Kwajalein, Eniwetok, Saipan, Tinian, Guam. Each of these invasions followed the same pattern. Assault troops would secure the island, and the Seabees would immediately begin construction. But as American forces moved closer to Japan, the scale of construction grew dramatically. The airfields built in the later stages of the war were not simple fighter strips. They were massive bomber complexes designed to support the long-range B-29 superfortresses that would carry the war to the Japanese homeland. The B-29 superfortress presented unique challenges. This was not just another bomber. It was the most advanced aircraft of World War II, a technological marvel that represented the cutting edge of American aeronautical engineering. The B-29 had a wingspan of over 140 feet. It weighed 70 tons when fully loaded with fuel and bombs. It had 4 massive engines, each producing over 2,000 horsepower. It could fly at altitudes above 30,000 feet, where Japanese fighters struggled to operate. It had a range of over 3,000 miles, meaning it could reach Japan from island bases in the Marianas. But these capabilities came with stringent requirements for the airfields from which it operated. The B-29 needed long, smooth, hard runways for takeoff and landing. It needed extensive taxiways and hardstands, because each aircraft was so large. It needed specialized maintenance facilities because of its complex systems, and it needed all of this in massive quantities because the strategic bombing campaign against Japan would require hundreds of B-29s operating simultaneously. The construction of the B-29 bases on Saipan and Tinian stands as perhaps the Seabees' greatest achievement. These islands in the Mariana Islands were captured in mid-1944 after brutal fighting. The Battle of Saipan lasted nearly a month and cost thousands of American casualties. The Battle of Tinian was shorter but equally fierce. Once secured, these islands became the primary bases for the strategic bombing campaign against Japan. Military planners determined that 5 major airfields would be needed, 2 on Saipan and 3 on Tinian, plus all the supporting infrastructure required for sustained bombing operations. The task of building these bases fell to the Seabees, and the scale was staggering. On Tinian, the Seabees built Northfield, one of the largest bomber bases in history. The complex included 4 parallel runways, each over 8,000 feet long and 200 feet wide. To put that in perspective, each runway was more than 1.5 miles long and wider than a 6-lane highway. Building just one such runway would be a major engineering project under peacetime conditions. building four simultaneously on a recently captured island in the middle of the Pacific Ocean, while the war continued to rage around them, was almost incomprehensible. Yet the Seabees accomplished it. The work required moving millions of cubic yards of earth. Tinian's terrain was not flat. It had hills, valleys, and irregular topography that had to be graded and leveled. Seabee bulldozers cut through hillsides and filled in low areas. They created drainage systems to handle the tropical rains. They built up the runway bases with layer upon layer of crushed coral, each layer carefully compacted to create a surface that could bear the weight of fully loaded B-29s, taking off and landing hundreds of times per day. But the runways were only the beginning. Northfield also required extensive taxiways connecting the runways to the parking areas. There were hundreds of hardstands, reinforced parking areas where individual B-29s would be parked, serviced, and loaded with bombs. Each hardstand was essentially a small airfield in itself, large enough to accommodate a bomber with its enormous wingspan and strong enough to support its weight. The Seabees built massive fuel storage facilities to hold the millions of gallons of aviation gasoline needed to keep the B-29s flying. They constructed bomb dumps where thousands of tons of high explosives were stored. They erected maintenance hangars large enough to shelter B-29s for repairs and overhauls. They built operations buildings, control towers, weather stations, and communication facilities. They constructed barracks to house the thousands of aircrew and support personnel who would operate the base. They built mess halls, hospitals, recreation facilities, and warehouses. They installed electrical systems to power the entire complex. They laid water lines and sewer systems. They built roads connecting different parts of the base and linking the base to other facilities on the island. Northfield was not just an airfield. It was a complete military city, rising out of what had been jungle and sugarcane fields, just months before the Seabees completed the first runway at Northfield in less than 3 weeks. The entire complex was operational within months. At its peak, Northfield supported 4 bomb groups, more than 600 B-29s, launching daily raids against Japan. The logistical magnitude of these operations was unprecedented. On a typical mission day, hundreds of B-29s would taxi to the runways in sequence, each aircraft carrying several tons of bombs and thousands of gallons of fuel. The bombers would take off at intervals, climbing into the Pacific sky and forming up into massive formations that would fly north toward Japan. Hours later, they would return, and the process would reverse. Hundreds of aircraft landing, taxiing back to their hardstands, being refueled and rearmed for the next mission. This ballet of aircraft and operations continued day after day, month after month, made possible by the infrastructure the Seabees had built. The Japanese watched as American bombers lifted off from Tinian by the hundreds, knowing those planes had taken off from runways built on an island that had been in Japanese hands just months earlier. Similar construction projects proceeded on Saipan and on other islands across the Pacific. On Iwo Jima, the Seabees landed just days after the Marines secured the island. Following one of the bloodiest battles of the war, Iwo Jima's existing airfields, built by the Japanese, had been heavily damaged during the fighting. The Seabees immediately went to work repairing and expanding them. Within weeks, Iwo Jima was functioning as an emergency landing field for damaged B-29s, returning from raids on Japan. The island's location, roughly halfway between the Marianas and Japan, made it invaluable as a refuge for bombers unable to make the full return flight. Thousands of American aircrew owed their lives to the Iwo Jima airfields that the Seabees built and maintained. On Okinawa, the last major island captured before the planned invasion of Japan itself, the Seabees built yet another extensive base complex. Okinawa would serve as the primary staging area for the invasion of the Japanese home islands. and the construction requirements were enormous. The Seabees built multiple airfields, port facilities to handle the invasion fleet, supply depots, hospitals, and all the infrastructure needed to support the largest amphibious operation in history. The work continued even as Japanese kamikaze attacks targeted the island and American forces fought to eliminate the last pockets of Japanese resistance. The Seabees worked through it all, building the springboard for the final assault on Japan. The psychological impact of Seabee construction speed on Japanese leadership cannot be overstated. Japanese military planning was based on the assumption that geography would provide strategic depth. Japan's empire was protected by thousands of miles of ocean and hundreds of island strongpoints. Japanese strategists believed that even if the Americans captured some islands, it would take so long to develop them into effective bases that Japan would have time to reinforce other positions or negotiate a favorable peace. The Japanese had experience with military construction in the Pacific. They had built bases throughout their empire and understood the challenges involved. Their own engineers and construction units worked according to established timelines that assumed certain minimum periods for various types of projects. A major airfield, in Japanese planning, required 3 to 6 months to construct from scratch, possibly longer depending on terrain and available resources. This assumption was built into every Japanese defensive plan and strategic calculation. But the Seabees shattered this assumption. Every island captured became a fully operational American air base in a matter of weeks. The protective buffer of distance that Japan had counted on evaporated. American air power moved closer to the Japanese homeland, at a pace that Japanese planning had considered impossible. As American bombers began reaching targets that Japanese planners had believed were safely beyond American range, confusion turned to alarm. How were the Americans doing this? What new technology or technique had they developed? Japanese intelligence officers struggled to explain the phenomenon. Some theorized that the Americans must be using some kind of new construction material that could be laid down rapidly. Others suggested that the Americans had developed prefabricated airfield components that were being assembled on site like building blocks. Still others wondered if American intelligence had somehow obtained Japanese construction plans and was simply completing the work the Japanese had already started. None of these theories was correct, but they reflected the Japanese military's inability to accept what was actually happening. Captured Japanese documents from the war reveal this confusion and alarm in stark detail. Intelligence reports describe unexpected American construction capabilities and impossible construction speeds. Staff studies attempt to calculate how the Americans are accomplishing these feats, running through various hypotheses and rejecting each one as implausible. Some Japanese officers theorized that the Americans must have prefabricated entire airfields and were simply assembling them on site, not realizing that the truth was even more impressive. The Americans were building from scratch in combat conditions at speeds that Japanese military engineering simply could not match. One captured report from a Japanese naval intelligence officer stationed in the Marianas before their capture describes watching American construction operations through binoculars and being unable to reconcile what he was seeing with his understanding of engineering timelines. He reported that American heavy equipment appeared to operate continuously, day and night, without the lengthy maintenance periods that Japanese equipment required. He noted that American work crews seemed to function with unusual coordination, as if they had worked together for years. He observed that the Americans appeared to be using local coral as a primary construction material, eliminating the need for massive supply shipments. His report concluded with a stark warning. American construction capabilities represent a strategic threat that current Japanese planning does not adequately address. This intelligence failure had strategic consequences. Japanese defensive plans consistently underestimated how quickly the Americans could bring new bases online, leading to a cascading series of defensive failures as American air power leapfrogged across the Pacific faster than Japan could respond. Each time the Japanese established a new defensive line, expecting it to hold for months or years, American bombers operating from newly built bases would be attacking behind that line. Within weeks, the Japanese would rush reinforcements to threatened positions, only to find that those positions were already under attack from airfields that should not yet exist. The entire Japanese defensive strategy, built on assumptions about time and distance, collapsed in the face of Seabee construction speed. Japanese forces found themselves constantly reacting, constantly retreating, constantly surprised by how quickly American power projection was moving forward. The strategic initiative passed entirely to the Americans, and much of that advantage came from the simple fact that the Seabees could build airfields faster than the Japanese believed possible. The human cost of this achievement must also be acknowledged in fuller detail. The Seabees operated under conditions that tested the limits of human endurance in every conceivable way. They worked in tropical heat that regularly exceeded 100 degrees Fahrenheit. The combination of temperature, humidity, and physical exertion created conditions that would have been considered dangerous under occupational safety standards. Heat exhaustion and heat stroke were constant threats. Men would collapse at their workstations and have to be carried to the shade, given water and salt, and allowed to recover before returning to work. Some never recovered fully and had to be evacuated. The heat made metal equipment surfaces hot enough to cause burns on contact. Bulldozer operators would wrap their steering levers in cloth to protect their hands. Men working with metal tools would sometimes drop them involuntarily when the heat became too much to bear. They worked in rain that turned construction sites into mud pits. Pacific rainstorms were not like rain in the United States. They were tropical deluges that could drop several inches of water in an hour, transforming a construction site into a swamp in minutes. Runways under construction would become rivers of mud. Equipment would bog down and have to be pulled free by other machines. Work would continue anyway. The Seabees would slog through the mud, operating their equipment, moving materials, doing whatever was necessary to keep the project moving forward. They learned to grade the construction site with proper drainage in mind, creating channels and ditches that would carry water away before it could pool and create problems. But in the meantime, they worked in conditions that would have shut down any civilian construction project. They worked on coral that tore through boots and equipment. Coral is not a forgiving material. It is sharp, abrasive, and harder than most people realize. Walking on coral tears up boot soles within weeks. Working with coral wears down equipment at an accelerated rate. Bulldozer tracks would wear out faster than normal. Cutting edges on grader blades would have to be replaced constantly. The fine coral dust that hung in the air around construction sites got into everything: machinery, equipment, clothing, food, water. It was abrasive enough to cause mechanical wear and fine enough to penetrate even sealed containers. Seabees learned to wrap critical equipment in multiple layers of protection. They learned to clean and maintain their machinery constantly. They learned to accept that equipment would wear out faster in the Pacific than it would anywhere else, and they dealt with it. They worked while fighting tropical diseases that ravaged the Pacific forces with devastating efficiency. Malaria was endemic throughout the Pacific theater. Despite extensive anti-malarial measures, daily doses of atabrine, mosquito netting, insect repellent, drainage of standing water, malaria still struck thousands of Seabees. The disease would lay a man low for days or weeks with high fevers, chills, and debilitating weakness. Some men suffered recurring bouts of malaria for the rest of their lives. Dengue fever was another constant threat, bringing excruciating joint pain that earned it the nickname breakbone fever. Dysentery swept through units regularly, caused by contaminated water or food, despite all precautions. Men would lose dangerous amounts of weight in a matter of weeks. Fungal infections thrived in the heat and humidity, causing skin conditions that were maddeningly persistent. Tropical ulcers, open sores that refused to heal in the humid conditions, afflicted many Seabees. These ulcers could become so severe that men had to be evacuated for treatment. The cumulative effect of these diseases sapped strength, reduced efficiency, and wore down morale. Yet the work continued. Men would work through malaria when they could. They would accept medication and return to duty as soon as possible. The construction schedule did not allow for extended sick leave. They worked under constant threat of enemy attack. Japanese artillery, air raids, and naval bombardment were regular occurrences at forward bases. On Guadalcanal, the pattern became grimly routine. During the day, Japanese artillery in the hills would shell Henderson Field intermittently. Seabees would work between the bombardments, taking cover when shells came in and returning to work when they stopped. At night, Japanese warships would approach the coast and shell the airfield with their naval guns. The attacks became so predictable that they were nicknamed Louis the Louse for the Japanese reconnaissance planes that would circle overhead at night, and Washing Machine Charlie for the distinctive sound of the Japanese bombers' engines. The nightly bombardments meant that sleep was constantly interrupted. Men would wake to the sound of incoming shells, grab their helmets and rifles, and dash for the nearest shelter. After the bombardment ended, they would try to get a few more hours of sleep. Before dawn brought the start of another workday, Seabees were killed by enemy fire while operating bulldozers. There are numerous documented cases of Seabee equipment operators being shot by Japanese snipers while working. A bulldozer cab offered no protection against rifle fire. Operators learned to keep their heads down and to vary their patterns to avoid becoming predictable targets. But sometimes it was not enough. A sniper's bullet would find its mark, and a Seabee would slump over his controls. His fellow workers would pull him from the machine, call for medical help if there was any hope, and then someone else would climb into the bulldozer and continue the work. The runway had to be built. The mission could not wait. This was the harsh reality of Seabee service. They were construction workers in a combat zone, and both roles carried deadly risks. They were wounded while laying pierced steel planking. The work of installing the interlocking metal plates was physically demanding and required men to be exposed in open areas. Japanese mortar teams learned to target construction sites where Seabees were working. Mortar rounds would arc in from concealed positions and explode among the work crews. Shrapnel would tear through flesh and bone. Men would go down screaming or simply fall silent. Medical corpsmen attached to Seabee units would run forward under fire to render aid. Sometimes they could save a wounded man. Sometimes they could not. The casualties would be evacuated, and the rest of the crew would return to work. Every Seabee understood that this could happen. They had all seen friends killed or wounded. They had all attended memorial services for men who would not be going home. And they continued to work because stopping was not an option. They died from accidents with heavy equipment. Construction work is dangerous even under ideal conditions. Operating bulldozers, cranes, and other heavy machinery requires constant vigilance and proper safety procedures. In combat zones, working around the clock, under stress and exhaustion, accidents became more frequent. Equipment would roll over on unstable ground, crushing operators. Cables would snap under load, whipping through the air and killing anyone in their path. Men would be struck by moving machinery or falling materials. Some accidents were the result of exhaustion, a moment of inattention after 16 hours of continuous work. Some were the result of working in darkness without proper lighting. Some were simply the inevitable consequence of operating dangerous equipment under dangerous conditions. The Seabees tracked these casualties carefully and worked to improve safety, but they could not eliminate the risks. Construction in a war zone was inherently hazardous, and men died building the bases that would win the war. They died from tropical diseases, from exhaustion, and from heat stroke. Not every Seabee casualty came from enemy action. The Pacific environment itself was lethal. Men who seemed healthy would suddenly collapse from undiagnosed conditions. Heat stroke could kill in a matter of hours, if not treated immediately. Infections that would have been minor in a hospital setting became life-threatening in field conditions. Some men simply wore themselves out, pushing their bodies beyond their limits until something broke. The medical facilities available to the Seabees improved as the war progressed, but in the early campaigns, medical care was primitive. A man who collapsed in the field might be hours away from anything resembling a hospital. By the time he received proper treatment, it might be too late. The Seabees earned numerous combat decorations, a fact that distinguished them from most construction units in military history. They earned Navy Crosses, the Navy's second highest decoration for valor, for acts of heroism under fire. They earned Silver Stars for gallantry in action. They earned Bronze Stars for meritorious service in combat zones. They earned Purple Hearts for wounds received in action. These decorations were not honorary or symbolic. They were earned through the same kind of courage and sacrifice that earned decorations for infantry and Marines. A Seabee who continued operating his bulldozer under heavy fire to complete a critical runway repair earned his decoration just as surely as a Marine who charged an enemy position. A Seabee who defended his worksite against a Japanese attack earned his decoration through the same kind of courage under fire. The Seabees proved that construction workers could be warriors, and their decoration records reflected that dual role. Individual stories of Seabee heroism illustrate the extraordinary nature of their service. On Guadalcanal, a Seabee bulldozer operator named Lawrence Meyer continued working on the runway while under direct Japanese artillery fire because a squadron of Marine fighters was due to land within the hour, and the runway had a crater that would make landing impossible. Meyer operated his machine under incoming shells, pushing coral into the crater and compacting it while explosions burst around him. He completed the repair just minutes before the fighters arrived, then drove his bulldozer to the side of the runway and waved the aircraft in to land. He received the Navy Cross for his actions. There were dozens of similar stories, Seabees who performed extraordinary acts of courage and dedication because the mission required it. The toll was not just physical. The Seabees spent months, and sometimes years, deployed to remote Pacific islands, living in primitive conditions that ground down the spirit as surely as they exhausted the body. Seabee camps were functional but Spartan. Men lived in tents that offered little protection from heat, rain, or insects. They slept on cots if they were lucky, on the ground if they were not. Their diet consisted primarily of sea rations and whatever fresh food could be obtained locally, usually very little. Fresh meat, vegetables, and fruit were rare luxuries. Most Seabees subsisted on canned rations supplemented with rice and whatever they could scrounge. Weight loss was universal. Men would arrive in the Pacific at healthy weights and lose 20 or 30 pounds within months. Some lost more. The combination of hard work, tropical heat, poor diet, and disease created a wasting effect that was difficult to counter. The Seabees endured long separations from home, often going months without reliable mail and powerless to help with crises unfolding far away. Older men with families and careers felt this strain most acutely. Combined with constant danger and exhausting labor, the psychological burden was immense. They also witnessed frequent deaths, friends lost to combat, disease, or accidents, mourning briefly before returning to work because the mission demanded it. Despite this, the Seabees performed with extraordinary consistency. From 1942 to 1945, they built airfields, bases, roads, ports, and infrastructure across the Pacific at a pace previously thought impossible. Their work enabled the island-hopping strategy, allowing captured islands to be transformed into active bases in weeks instead of months. This speed made American air superiority, submarine operations, logistics, and strategic bombing possible. By 1945, Seabee-built bases formed the backbone of the Pacific War effort. B-29s striking Japan launched from runways they constructed. Submarines strangling Japanese supply lines operated from ports they built. Their infrastructure, airfields, docks, hospitals, fuel depots, roads, pipelines, and housing supported every American advance and shortened the war by months or years, saving countless lives on all sides. When the war ended, the scale of their achievement was undeniable. Over 100 major airfields, vast port complexes, millions of tons of concrete, billions of cubic yards of earth moved, and complete utility systems built on islands that had been little more than jungle or coral. They built under fire, in brutal climates, and in terrain civilians would have deemed impossible. The Seabees proved that rapid, adaptable military construction is a decisive element of modern warfare, a legacy that shaped military engineering long after World War II.